right? We discuss about the physical computing and what is meant by physical computing, right? So basically, it should be a kind of interactive physical system, right? So it basically sensing analog world, that means our environment, right? So it's sensing the environment, can be some like humidity, temperature, whatever those uh, aspects. Then it should do some activity, right? Using the actuators, we call the sensors the same. Then the output will by using actuators, right? So then I discuss about several sensors we have, then the actuators, right? Then like that we, yeah, then the overview. So these things we should cover, right? Then we started discuss about the microcontrollers and what is meant by microprocessor and what is the difference between two, right? Then in the microcontroller, the basic is it has all the component it needs, right? If it needs some memory, random access memory, it has that memory, right? If it needs some interrupts, it has those interrupts, those things, right? If it needs some IO ports, it has all the necessary things inside the microcontroller, right? Then if you can see, compare the pricing with the microprocessor, basically very cheap, right? Then so that was the first part. Then we discuss about the second half, why we need Arduino, right? So what is Arduino? It's basically open source community. It has so we have open source boards and software support as well. And basically we use it because we can like so it is very inexpensive, right? So then we can do some prototyping things, like, so not just the actual systems, but we can prototype our ideas, right, in very weekly manner, right? So that's why we use Arduino, right? Then we have we discuss these things, and we discuss the components of Arduino board, right? So it basically it has a microcontroller, right? So Arduino is a kind of a development board with the microcontroller, right? So if we directly go to like a program in the microcontroller, that will be hard work, right? So by using the Arduino, we have the interfaces, right? We can use jumper cables or whatever, right? It has the like a very easy to prototype aspects, right? That's why we using Arduino rather than directly using the microcontrollers, right? Inside every Arduino, it has a microcontroller, right? So then it has a crystal oscillator that keeps the timing of the microcontroller, right? Then we have a set of pins. We have analog pins and digital pins. So the pins starting from A0 to A5 considered as analog pins. Then we have digital pin from 0 to 13, right? Then then we have ground pins, right? So then we have voltage pins as well, right? If you need to take some voltage out from this Arduino board, right? We can use either 5 voltage or 3.3, right? Then yeah, we have voltage regulator to regulate the voltage. So if we give a higher voltage, so that basically regulated by that regulator, then if it can't handle that voltage, that will be burned out, right? It will save the Arduino board, right? Then we have a reset button, right? So this is the reset button. right? So in the Arduino board, right? So if we put some kind of a program, it will run again and again, right? So in somehow we need to reset that behavior. We can press this button, right? It will then reinitialize all the things and restart the program, right? We have set of LEDs, right? So we can, so this LED basically coupled with this pin number 13, right? If we give some voltage to this pin 13, then this LED will light up, right? Then we have RX and TX LEDs as well, right? If you doing some kind of a communication thing, then if it receives receiving some data, it will light up the RX. Then if it is transmitting some data, it will light up the TX, right? Then we have the power on LED, right? So it shows whether that Arduino board is powered up or not, right? Then yeah, then the lecture 2 we discuss about the previous week lecture, right? In here we discuss the pins again, what are the pin mode we have, right? So if we are using if you need to take some sensor reading, right? So that is input. So in that case we should set the mode as input. Then if we need to like give some voltage out of pin, then we should set it as a output, right? Then yeah, in analog read, in here in analog read, that basically means if so we have kind of reading that coming from like analog world, right? So we are sensing analog world, right? Like suppose light intensity, whatever, right? So then we need to transmit that into, like translate that into the kind of a language that understand this Arduino board, right? So Arduino board is a digital thing, right? It can only understand zeros and one, right? So we should translate that analog reading into a digital thing, right? So for that we are using ADC, analog to digital conversion, right? So in our Arduino we have for every these analog pins we have ADCs, right? So we have yeah. We have 6 pins, right? So these are the 6 pins we have. Then it has a 10-bit converter, right? So as you can see, if we increase the number of bits, if we can increase, we can take a higher number of bits ADCs, then this conversion is very smooth, right? So compare these two, right? So like that we can take up approximately continuous signal, right? So we have 10-bit analog digital converter, right? So in that case we have 10 to the power 10, that means 1024 readings we can take, right? 1024 states we have. So the value should be, if we read some kind of a value from using this analog pins, right? It should be within 0 and 1023, right? Okay. So if you're reading kind of a very high value, so it will cap from 1023, right? So that is the higher value we can give. So it basically mapping, it's reading kind of a voltage, right? So it's mapping 0 to 5 range to see this 0 to 5 voltage. This range map with 0 to 1023, right? So by using simple math, you can, if you are reading kind of a value like 500 or whatever, right? Then you can do some maths and find the voltage, right? You should find the voltage. before you move on, right? So this, either you can do some stuff with this, the reading as well, but the correct procedure is to like convert this value into a voltage value, right? Then we have pulse width modulation, right? So as I said before, this analog, this Arduino is a digital thing, right? So it has only set of states, right? So it can either write, it can either give 0 or 1, right? So but if we need some kind of like scenario, like we need to reduce the brightness of the LED or reduce the RPM of a motor, like that, if you need to regulate the voltage, so for that we don't have a mechanism to do that, right? So because of that we can use PWM. It's a kind of a tricky thing, like so since we have kind of a clock like 16 megahertz, right? By using this clock, we basically give some like pulses, right? So we can give either 0 or 5, right? So either we can give continuous 0 or continuous 5, right? So what we're going to do is we give some small time durations, right? So we give like 100 millisecond for 5 voltage, and the rest of the time will be 0. Like that, we are pulsing, give some pulse signals, right? So these pulse signals, we are like talking about like a 16 megahertz clock, right? So in that case, so these pulses will be identified from the analog analog world, like lowering in the voltage, right? So it's just like kind of illusion, right? So this LED, if you consider LED, right? So this LED thinks that, so he getting kind of a reduced voltage, right? But actually we are giving 0 and 5 voltages with this kind of time durations, right? We like keep on offing a switch, right? So we keep on for 100 milliseconds, then keep off for 500 milliseconds, like that. By doing this, so the LED thinks like, okay, I'm getting kind of a reduced voltage about 2 voltage or 3 voltage, right? So that is the pulse width modulation, right? Then for that we are basically using analog, right? So we have 4 main types, right? We can do digital write, digital reading, then analog write and analog read, right? If it is starting from digital, the name digital, so that there is no issue. But if it is analog and it is kind of a writing thing, right? For that we have special, we should use special pins, right? So we call those pins as PWM pins, right? We have set of pins in the Arduino board. So these are the 3, 5, 6, 9, 10, 11. So this is specifically for the Arduino Uno, right? So if you consider Arduino Mega or something like that, it has a high number of PWM pins, right? And then we have 8-bit PWM converters, right? So that means we can write either value from 0 to 255, right? So 2 to the power 8 is 256. Then with 0 you have 256 states, right? So this 0 to 255 value is mapped with 5 voltage, right? So if you give some kind of a 127, so that is like 2.5 voltage, something like that, right? Then that is the things we discussed. Then we compare several Arduino boards actually. Then so these Arduino boards differ from like number of inputs and outputs. It have like IO pins, then the clock speed, then the operating voltages and the form factors, right? So these are the kind of different Arduino boards we have, right? Then we compare some memory aspects as well, right? Then so this is the comparison we did, right? So as you can see, Arduino Mega is the king, right? So it has the high number of memories, right? So but the form factor is very large, right? So if you don't need that kind of if you don't have that kind of a requirement, you shouldn't use that board, right? So that basically wasting this your money, right? Then we discuss about the types of memories we have, right? So SRAM, the static RAM. So we basically create the sketch mean the Arduino program. Then we have the flash memory. So that is the place where we stored our Arduino program, right? Then we have EEPROM. That basically means, so if we need to save some kind of program data rather than storing in the RAM, right? So you can use EEPROM, right? Then yeah, you know that flash memory and EEPROM is normal, right? That means if you even power off the Arduino, right? So those data will be still reserved, right? Then in Atmega, this chip, we have around this much of flash memory and RAM and the EEPROM. Then if you consider the Arduino Omega Atmega 2560, so it has about the higher values, right? So it has about 256 flash memory and 8 kilobyte static RAM and the 4 kilobyte EEPROM, right? Then yeah, we done some programming using so this is the Arduino IDE, right? So with the code situation, we can't conduct any physical practicals. So for that, we are using Tinkercad, right? So I think I asked you guys to sign up for Tinkercad, then join this class link as well, right? Yeah, then yeah, in every Arduino program, it should have a setup and loop function, right? So the setup means that basically setting up the environment, right? So it only runs at the first execution, right? So unless we reset, so it will run only for once, right? So it basically initialize the variables and setting the pin modes, those stuff we done on setup function, right? Then we have a loop function, right? So loop function basically means it's run over again, right? So it's starting after the, so basically the execution will start from like this, right? So it first run the setup for one, then come to the loop, then it is executing all the instruction. Then if it come to the end of the execution, then it will start again, right? Like that, this will be run forever, right? Unless we reset in the power of the Arduino. Then we discuss about some basic functions, the pin mode, right? So if you are reading some sensor data, that basically means the input, right? So we should specify the mode dash input. Then if we are give some writing some value out of a pin, that basically means that is the output. Then we should set the pin mode dash output, right? Then as I said before, we don't need to specifically define the pin mode for analog pins, right? Because we can only use analog pins as inputs, right? Then yeah, then the digital write. So that basically means if it is starting from the digital, that means that is okay, right? You can use, you should use digital pins, right? So you should specify the pin number and the value, right? So since this is a digital write, so you can only write, you can specify the pin, then you can either put 0 or 1 here, right? So if we put low, that means 0, then that means 0 voltage, almost 0 voltage. Then if you put high means number 1, that basically means almost 5 voltage, right? So So these things, these voltage levels are not very accurate, but it's almost have some error, but it almost nearly 0 and 5 voltage, right? Then we have digital read. So the output will be 0 or 1, right? Because it is starting from digital, right? So we should use a digital pin, right? Then, then we have analog read, right? So in analog read, as I said before, we have analog to digital conversion, right? In that case, yeah.
මේ ආඩුවන බෝඩ්ඩේ සර පහ පෝල්ට අමතර 3.3 වෝල්ට් කියලා එකක් තියෙනවා සර් මේ
Oh,
අපි ඒකට මේ සෙට් කරලා හයි කියලා ගත්තොත් මේ ඒක නේ සර් ගන්න එතකොට ඒ වේරියබල් එක ඒ අනුව වෙනස් වෙනවද ඔය මේ ඩිෆයින් කරලා තියෙනවා
නෑ. ඒක ඒවා කියන්නේ ARF pin එක ගැනද නැත්නම් 5 voltage 3 voltage ගැනද?
ඔය සර් මේ අර තියෙන්නේ පල්ලෙන් අර මේ ඇනලොග් ඒරියා තියෙන්නේ 5
නෑ. එතන මෙහෙමයි වෙන්නේ. Right. So in here, right, so you can either write voltage from these pins, right? So you can, as I said before, this, so some pins, most of the pins it has a different functionalities, right? So in some case it act as an input, in another case it can act as an output, right? So these things you can use for some kind of a sensor reading, so like giving some outputs, those stuff, right? But these things are only for taking out the voltages, right? So if we need to power up some kind of suppose sensor, right? So I'll do some sensor in today's lecture, right? So suppose you need to power up some temperature sensor, right? It has we should give some power to that sensor to power up, right? In that case you should give 5 voltage, then you should ground the sensor. Then the third pin basically we are using for transmitting the data, right? In that case you can use that this pin connect to this kind of a digital pin or analog pin, right? So the thing is, so don't make it confused with these writing values out of these digital pins, right? So these are just to take out some kind of power out of those pins, right? So if you need to power up LED, right? In that case, you should connect these 5 voltage with this. Is it clear? So these things only for the purpose of.
අපි දැන් උතනින් අර ඒ දෙක සෙට් කළා අනිත් එක මේ උතන මේ PWM පින් එකකට හරි මොකක් හරි පින් එකකට හයි කළා සර් මේ ඊට පස්සේ අපි ගන්නවා සර් ඒකේ අවුට්පුට් එක දැන් LED එකක් වගේ අර ඒක සමානයි හයි නම් වගේ ඒකට හයි කියලා අදහස් කරන්නේ දැන් අර උතන පහ සෙට් කරොත් පහයි 3.3 සෙට් කරොත් 3.3 එහෙම නේද හයි කියන එක මං අහන්නේ මේ
නෑ මේකත් එක්ක මේ එකක් නැහැ ඒක. මෙතන තියෙන ඔයාට PWM මෙහෙම දැන් PWM පින් එකක් මෙහෙම දැන් අපි හිතන්නකෝ LED එකක් කියලා. අනේ LED එකේ අග්‍ර දෙක තියෙනවා. මේකේ output වෙන්න ඕනේ. මේ අග්‍ර දෙක තියෙනවා මේ අපි එතකොට දැන් එක පින් එකක් කොහොමද ground කරන්න ඕනේ? minus පැත්ත ground කරන්න ඕනේ. හරි විදිහ නම් ඒක අනිත් පැත්ත කරන්න ඕනේ. මම දැනට කියන්නම් minus පැත්ත ground කරන්න ඕනේ. හරිද? එතකොට අනිත් අග්‍රයට දෙන්නේ මොකක් හරි මේ voltage එක. හරිද? ඔයාලට මේක LED එක පත්තු කරන්න විතරයි නම් ඕනේ. ඔයාලට කෙලින්ම මෙන්න මේ pin එකට set කරාම ඒකට voltage එක යනවා. ඒක පත්තු වෙනවා. clearද?
ඕක.
හරි?
excuse me sir.
yeah.
ඒ කියන්නේ සර් මේ දැන් power output pins වලටයි මේ microcontroller එකටයි මේ connection එක නැහැ ඒක constant voltage supply කරනවා කියන එක.
It's just supplying the voltage, right?
Okay,
we can't regulate that aspect, right? But so then suppose you need to give some blinking or something like that, right? So you can't code these pins, right? For that, you should use a digital pin, right? So for a digital pin, you can say, okay, now blink, now write high voltage, then stay for a second, then write low voltage, like that, right? But if you give some, if you plug those pin to this kind of a voltage pin, that basically give kind of a constant value, constant voltage. Okay, you can't program these voltage pins or ground pins, right? You can't only work with these digital pins and the analog pins, right? You have a set of functions to do that, right? You can, by using those functions, you can implement some kind of several behaviors, right? Is it clear? Okay, so if you need to there is a mechanism to refer some kind of outage voltage, right? If you need to go refer some, suppose you need to refer some value like 10 voltage, right? So by, suppose you have a scenario like, so using some kind of a very high sensor, right? So the output will be kind of a 10 voltage or whatever, right? So by using these analog pins, you are capped with the 5 voltage, right? So the maximum voltage you can sense is 5 voltage, right? But the thing is, in this scenario, that sensor gives some output like 10 voltage, right? So suppose this Arduino board won't burn, right? Then in that case, you can use this ARF pin, right? You can give some higher voltage to that pin. Then this 5 voltage cap will increase to that, you giving that voltage, right? If you give some 10 voltage, you can have that 10 voltage as the higher limit, right? That is a different story, right? So in this case, these voltage pins, we can just to take some output out of this Arduino board, right? It just continuously giving kind of a, if it is 5 voltage, then it continuously giving 5 voltage, right? If it is a 3.3 voltage, it just gives 3.3 voltage, right? So there are no functions to change the behaviors, right? It's just the hard-coded things, right? It's just the behavior of the ground, right? But in these analog pins and the digital pins, right, you have set of inbuilt functions, right? So rather than lighting up the LED, if you need to blink the LED, in that case, you can use this kind of a pin. Then you can give some time delays that, okay, now it's time to light up. Okay, now we should, now it's time to turn down the, turn off the LED. Like that, you can set your instruction on the program, right? But in these voltage pins, you can't do that, right? It just continuously supplying the that 5 voltage or 3.3 voltage. Okay. And
Sir,
yeah,
මේ RX TX pins දෙක අපිට use කරන්න බැරිද වැඩවලට?
පුළුවන්. RxTX pins use කරන්න පුළුවන්. මේ ඒක තියෙන අපි normal behavior එකේ තියෙන්නේ RxTX අපි use කරන්නේ මම හරි communication purposes වලට තමයි. But still there is a digital pin, you can use that, right? So this every pins has
ඒකස මම අර මේ LED දෙක ගහලා ඒ කියන්නේ run කරාට පස්සේ අර කියන්නේ
error එකක් එනවා.
signal එකක් දෙන්නේ නැතුව මොන් වෙලා නෑ on වෙලා තිබ්බනේ සර් signal එකක් දෙන්නේ නැතුව.
ඔය signal එකත් මෙන්න signal, you don't need to specifically like, so that's why I tell that these RX and TX pins are used for the kind of communication purposes, right? Serial communication. Then so did you specify this as an input to output at the setup file setup?
Yes
Right.
as output.
Okay, so in that case the things will be like so that is basically used for the communication purposes. You are burning that means you are burning means like you are programming the Arduino board, right? In that case, so that these things will communicate these voltage levels, right? In that case, if you plug kind of LED to that pin, so that will be basically light up, right? Okay, right? So normal behavior is if you plug some RX or TX things, some sensor to RX and TX, if you use the Arduino IDE, so it can't actually communicate the, it can't actually burn means like program the Arduino, this controller, right? In that case, you have to pull out the connected pins after you program it. Then you can plug in these your pins, right? So that's the normal behavior. But in, I don't know whether when you're doing the simulation one, I don't know what the behavior is. But the normal thing, if you are connecting some like inputs or output things to this RX and TX, right? So if you program in this Arduino board, right? So it will communicate through serial communication, right? So if you give some inputs, right, that means you are giving some voltage to this RX and TX, and that will like it will interrupt the communication, right? So this in the normal behavior, we have a computer, right? In computer, we program in the Arduino board, right? Then so it communicates to serial communication. I'll do the communication part on the next week, right? So in that case, if you are giving some input values, input voltage to these two pins, right, that will interrupt this communication, right? So then it will fail to program the Arduino board. It will give an error, so it can't communicate with the Arduino board, right? In that case, you have to remove these pins, remove your connections with the RX and TX, right? Then program the Arduino board. After that, connect your sensors or whatever to this RX and TX, right? So that is the normal behavior. Okay, right? So if it is light up, then that means it has kind of a communication or something happen on the Arduino board in the simulation, right? So that's why it's light up, right? So some
Okay, sir.
aspects,
Thank you.
some aspects are different. Like when we are simulating, we can't expect the actual scenario, right? That's normal, right? So in here we just need to you guys should familiar with the Arduino environment and how to use set of sensors, and those things will be enough, right? Then yeah, we discuss about the digital write. Then we were at analog read, right? So the maximum value will be if you're using analog reads, right? If it is analog, then it is a read, then you should use the analog pin A0 to A5, right? So the this value will be around 0 and 1023, right? So this is just a reading, right? So this is not the actual voltage, right? So you can simply divide these two and get the final voltage, right? Then then we have this analog write. So analog write we should do in the PWM pin, right? So that is first part is analog, right? But the second part is write. Write means you can't do analog writing. That means you can give some continuous signal out of this digital Arduino board, right? So in that case, we are faking this analog world, and we are using PWM pins, right? So the maximum value will be 255, right? So you can write 0 to 255 values, right? Then so this voltage level, if you write 0 or 255, that doesn't mean that is it doesn't have a very like a good precision, but the thing is it almost 0 voltage and it almost 5 voltage, right? It has a kind of error, right? So that is normally like we are just prototyping this stuff, no, right? So in that case, that will be okay, right? Then we discuss these looping structures and if fails, then the assignment 2, right? So yeah, that is the end of these two Someone else, can we use digital write for PWM pins? Digital write. So digital write, if we use digital write, that basically at the first part is a digital, right? So that means it has only 2 states, right? So you can do digital write on a PWM pins, right? So that's the thing I said before as well, right? So these pins can act as a different functionality it can have, right? So if we consider these, right? In some cases, right? So in here, so you have the key here, right? So you can see if it is this color, that is a port pin, right? So this is a port pin, and if it is blue color, that basically means it's a serial pin. So it can act as a port pin. Also, it can act as a serial pin, that for the communication purposes, right? Then if you consider this pin number 3, right? So pin number 3, we have this color that basically for interrupts. We're going to discuss that part today, right? Then so it has, so in here you can see it marked as this kind of a curved thing, right? So that means obviously this is a digital pin, right? So if we have this this color, that basically means it can act as a PWM pin, right? If we need that functionality, we can get that functionality out of from this pin, right? But if you didn't need that functionality and we just need to get the normal voltage or something like that, do the digital writing or something like that, we can do that thing as well, right? So one pin can act as a set of pins, right? So it's sometimes it's used for serial communication. Again, you can use for writing digital signals. Again, we can use that for PWM signals, like that. That's why. So for the, like, we can use those the same pin, like for like different purposes, right? Okay, so that's the end of the previous lectures. Then can move for the today's lecture. Right, so we first going to discuss some briefly about data types and variables we have, then how to use sensors, then the interrupts, right? So variables, we have this kind of variable, we have int and unsigned int, right? So the value range will be like this, right? We have 2 bytes int, right? That basically 2 to the power 16 states we can hold, right? If it is unsigned, that basically means we we cut out the negative part and we only take the positive part, right? So that basically double the value range, right? Then we have long. Long means 4 bytes, that basically 2 to the power 32. So the value range will be look like this, right? For unsigned long, and so the value range will be like this, okay? Then then we have float and double, right? So in Arduino, we can treat float and double as almost same, right? But in the normal case, we have, in double is much precision have, but the thing is, in this case, we consider these float and double as same, right? So the so the value range will be look like this, 4 bytes, right? Then we have char, right? 128 to 127, right? And then we have unsigned char, so that will basically double the value, right? Then we have byte, boolean, right? So those are the main data types we're going to use, right? Then so the example will look like this. If it is an int, so the value will be integer, right? Then if it's a string, so the value will be kind of a character array, right? Then if you need to cast some value, right, we can do that as well, right? So if you need to round up this 4.61, so this will be round off to 4, something like that, 4 or 5, right? So so that is the some brief introduction about the data types we have. Then we go to the discuss how to use the sensors, right? So that's the good part, right? So in most of the sensors, right, most of the sensors, we have 3 pins, right? So the first one to power up that sensor, right? That is the voltage pin. We should give some positive voltage to that end, right? Then we have ground pins. So by defining these two, by connecting these two, so now the sensor is activated, right? Sensor is now turned on, right? So then I said most of the sensors have 3 pins, right? So then the next pin we are using to communicate the data, right? So that is a data pin, right? So if it can be either that communication, that value will be the 0 or 1, or it can be have analog value range as 0 to 1023, right? So so we are just referring some value, right? So if you are using analog sensor, right, if you are getting some analog feed, in that case we need to convert that number, right? Suppose we get, so we have some sensor, we plug it into Arduino board, right? Then we read the value that that pin gets. Then suppose that value is 500, right? So this is not a kind of a voltage thing, right? So this is just a number, right? So we should divide with the, so divide and take the voltage out of this 500. What is the voltage that for this 500, right? So this is just a number, right? You have to keep it that mind. So after getting some analog read, you getting some kind of a value, right? So we need to translate that value into a voltage value, right? So then, right, you can refer the data sheet for that, right? After you get that voltage, in the data sheet you have like voltage with that suppose you are using some temperature sensor, right? So it defined the voltage levels with the temperature, right? Suppose Celsius, right? So if you know the voltage level, then you can refer the data sheet that function, there are set of functions. That means function mean like okay, function means like the dependency between these two, right? So first you get kind of a value, right? So out of this, after reading, you get some suppose value from, if it is analog sensor, you get some analog value, right? Then in the data sheet, it defined, suppose if it is like a temperature sensor, it defines. So if that sensor give this much of voltage, that means so the Celsius or the temperature should be kind of value like this, right? So it has that plotting, right, in the data sheet, right? You should refer that plotting, and you should convert this voltage value into this your measuring unit. That it can be like temperature, like if it's Celsius or Fahrenheit, whatever, right? So first we are starting from sensor value, right? That value we are taking out of our analog pin, suppose A0, to taking out some value like 500, right? Then you convert this value into a kind of a voltage value, suppose 2 voltage or whatever, right? Now we have the voltage value in the data sheet. It defined the function with the voltage with the temperature, right? So if it is give this kind of voltage, suppose 2, then it should, the temperature should be like 30 Celsius, so whatever, something like this, right? So you need to refer the data sheet and do your work. Then you can convert this 2 voltage into some measuring unit like 30 Celsius or whatever, right? So you have to keep in mind. So this is the procedure, right? So either you can do it by your own, or you can do it by using set of libraries, right? Most of the most of these sensors come up with the library, right? So you can just read the sensor value. out of the analog pin or whatever, right? If you are using analog pin, you can just simply take out the analog read, suppose 500, that 500, right? Then this, by using this library function, in the library there is a special function, right, that will convert this 500 to some measuring unit, right? Some measurement, right? Can be 30 Celsius or whatever, right? Like that, either you can do it by your own. If it has the library, that will make your work easy, right? So that is the thing. So I'll show you how to use the libraries as well, right? So in this kind of temperature sensor, you don't come up with the libraries. We don't need the libraries, right? By using the libraries, there's another issue. Most of the libraries, some libraries have some errors, right? So you have to deal with that as well, right? So the best thing is to do it by your own, right? So, but if the scenario is complex, in that case, you have to go for the libraries, right? Is it clear, the procedure? Yes or no? I'll do an example anyway, right? So, right. Now, the thing is, now you know how to take a reading out of a sensor, right? Then the issue was, so have you, like, when you are like programming, you have the terminal, right? So you can you can use that terminal to print some stuff, then you know, so this is there, those stuff. But in this Arduino board, you don't have that facility, you don't have a display, right? For that, but we have that thing called serial monitor, right? So by using serial monitor, we can do some work, we can print some messages, then you can use it for the debugging purposes, right? Or you can use it for the communication purpose as well, right? So in the serial monitor, if you go to the Tinkercad, right? In here, you have the serial monitor, right? If you start the simulation, you can see you can print the values on that serial monitor, right? So it's just like it, basically we can give inputs as well, right? Else we can print some values on the serial monitor, right? To use the serial monitor, you should first define the communication aspects, right? So you should first define what is the baud rate you are going to deal with, right? So first, when you are programming in the Arduino, right? So in the setup, you should specify the number of bits you're going to communicate to using this serial monitor, right? Serial communication, right? For that, you can use this serial.begin, right? So begin means you're going to start the communication, right? So the baud rates, there are a set of baud rates, right? In the default case, we are using 9600, right? Then we have going to, like, we can either use this kind of baud rate as well, right? So you are defining the number of bits you're going to communicate using this serial communication, right? In Arduino, this Tinkercad, you don't have to, you just need to specify okay, we have this serial begin here, right? So in here you set up the baud rate in the code, right? But if you're using Arduino IDE, you can take the serial monitor by Control-Shift-M, I think. By pressing Control-Shift-M, you can take the Arduino, the serial monitor. In serial monitor, you have to specify your baud rate as well, right? In the Arduino IDE, there are two places to set the baud rate, but in the Tinkercad, you just need to set the baud rate in the code. Then this serial monitor will configure to that baud rate, right? So if you're using the Arduino IDE, so that's not going to work. You have to set the baud rate in the code, and you have to, there's a set of items in the list, in the set of baud rate, right? 9600, 115, 200, like that. You have to click the correct baud rate that match with the baud rate you are coded in the Arduino program, right? Otherwise, it will print some gibberish in the serial monitor, right? So it should match with the correct baud rates, right? Then if you need to print something, you can use serial.print, and you can specify if it's a value, you can put the variable. Otherwise, you can put your message in the inverted commas, right? In using this print ln, you can print and give a new line, right? Then the same thing, if you serial.print and give a tab, you can use this for giving tab, right? So it will give some space, like printing some value, give some space, then printing some value like that. If you put this, then means if it's printing, then the next character will print in the next line, like that. You can use this serial monitor, right? Then if we go into, so I'm going to use this temp sensor to give you some idea, right? So it will be better if you can do it with me, right? Then if you can, please do, right? So in here, right? So if you don't remember how to do these things, right? You can click on Arduino, right? There are some pre-made ones. Click on the some. If it is blink, click on that and tap on this. Then this will be visible, right? Then you should go to the coding part, right? In default case, it will set to this block things, right? So you have to change that into text, right? Okay. In here, okay, wait, give me a second. Right, so it will reset my code anyway. So I have two sensors. I'm going to use two sensors, right? So right, so I'm going to use this temperature sensor called TMP36, right? Then I'm going to use this PIR sensor, right? So this PIR sensor we basically use to like so the application level, we basically used to find the movements, right? So it has kind of range, right? If it is within range, if we do some movement, that will be captured by this PIR sensor, right? We are using this TMP36 to measure the temperature, right? So I'm going to first use this PIR sensor, right? Here you have, if you remove this, in PIR sensor, as I said before, it has 3 pins, right? So first one is specified as ground, right? So you should plug it into ground pin, right? We have ground pins here. You have to plug it into ground pin. Then the next one, we have power, right? So then we should plug that power into 5 voltage, right? You should refer the data sheet, right? In data sheet, it's defined what is the operating voltage, right? If it is working on 3.3, then you should give 3.3, right? So otherwise it will burn, right? So refer the, I didn't refer the data sheet, right? So I'm just giving 5 voltage to this power, right? Then the third pin, that is for signal. Signal means the data, right? So I know this PIR sensor just gives some whether if it is detect some movement or not, right? So it kind of have a digital value, right? 0 or 1, right? Because of that, I'm connecting this signal pin into a digital pin, right? So now I have this connected one, right? Then, so what is the first thing, right? So we can remove this thing. We have set up an loop, right? So what is the first thing we should do? Come on, guys, we have around 1 hour to go, right? Yeah, what is the first thing? Come on, you have to speak up, right?
So
Yeah,
you have to set the input and output. of the
yeah,
pins.
yeah, pins. So pin mode, I can't remember this. So the pin I'm using is pin number 2. So that is, so I'm reading some value, right? So that basically means I'm taking that as input, right? So, right, I hope that is okay. No errors, right? Okay. Now you specify this pin number 2 as input, right? Input means you are sensing take some value out of this sensor, right? You are taking the reads, right? Then, so I need to take that value out of this sensor and put it in kind of a variable like this, right? So I'm using a digital pin. So in that case, we don't use digital read, right? Digital read. So pin number is 2, right? Now I have this value in my integer, right? I can give some delay, right, to make it smooth running, right? So delay, right? So now it has that reading value, right? So it will work like this, right? So so this is the range. This colored one is the range, right? So now I'm just simulating, right? So if we do some movement outside the range, it will not trigger. But if I do some movement inside the range, right? So this will light up, right? Then that tells that it detects some movements, right? Like that, right? Now I can't see what is the actual value, right? So for that, I'm going to use the serial monitor. Serial.begin. So the keyword is serial. Then you should initialize the communication. So I'm using the baud rate as 9600, right? Now the serial is initialized. Then I can print that value like this, right? So I'm going to print line by line, otherwise it's hard to read, no? Right? Serial dot print ln. I give ln to make a new line, then I put this value, this variable inside this function, right? Then I give 100 delay, 100 microseconds. Right? Now it's specified as 0. Then if I do some changes, do some movement inside this range, it will print as 1, right? If I go to this side, 0, right? Then if I slowly make some movement inside the range, then that will be 1. Again, if I stop the movement, it's printing 0. Okay, is it clear? How to use the serial pointer, right? Here you can set another baud rates. What someone asked me, what will happen if we use the analog read here, right? So we can use the analog read as well, right? So the first thing first, I should remove this and plug it to an analog pin, right? Suppose analog A2, right? Then analog read A2. right? It's just giving 0 and 1 value, right? So for 1, it has, if it detects some value, right, it basically gives some voltage, right? So the voltage value is by converting using ADC, so that value will look like this 1080, right? So if you use the digital read, it has to say 0 and 1, right? There is no purpose of using the analog read here because this sensor only have 2 states, right? It can either have not detected or it can have detected, right? Right. Someone asking, we decide the serial number, not the serial number means you mean the baud rate. Yeah, we should define the baud rate. That's correct. If you're using set of Arduino boards, right, we should defining the common baud rate for all the Arduino boards, right? Then, yeah, someone asking whether we need to change the pin mode for A2. No, right? Because we are using analog pins only as the inputs, right? In that case, we don't need to specifically specify this analog pin as a input, right? Obviously, we can use these analog pins only as the inputs, right? I think in the lecture slides as well, I mentioned that, right? You don't need to specify the pin mode for analog pins, right? Then someone asking whether we can use Boolean as well. I don't know. We have to check that one, right? We have to change the voltage value according to the distance. Yeah, someone asking whether we can change the voltage value, not in here, right? So that's why I tell that. So this sensor it's a digital sensor, right? It can only have 2 states, right? Whether it's detected some kind of movement, right? So if it's detected or not, right? 2, that means binary, right? Someone asking whether every board, both serial numbers. Muhammad, your question is not clear. In Kavishan, I think to change the voltage according to the distance, you can use this ultrasonic distance sensors, right? So it will give some range. It changes the voltage of that reading according to the distance, right? So I'll do the distance sensor in another lecture, right? Okay, so Muhammad, your question is not clear. Then I have my code here. I'm going to use that. Yeah, go ahead.
My question was, can we use both number, so that's 9,600 or 11,000 or 15,200 for any board? I mean,
Yeah, most of the boards supporting the same that baud rates, right? So the lowest one is I think 9,600. Then you can.
How can we decide what the suitable number for?
Suitable number, that depends on your scenario, right? So that basically this number basically defines the number of bits it can transmit for a second, right? So if you need kind of like higher number of high speed, or like if you have a bulky things, right? In that case, you can go with the higher number, right? So that depends on the scenario.
Okay, sir.
Okay, but you have to keep in mind, like if you are communicating between 2 or 3 Arduino boards, you have to come up with the same common baud rate, right? So otherwise, so it's like if these 2 numbers are different, then it's like speaking like single people speaking with Chinese people, right? They can't understand, right? Just a gibberish, right? So that's why we have to have common setup for all the things, right? Right. Now I use my code in the lecture slide, right? So I'm going to use this TMP sensor as well, right? EMP sensor basically sensing the volt, this temperature difference, right? Inside functionality, it gives some, if it has some changes in the temperature, that will reflect as different in the voltage, right? So if suppose it is 100 Celsius, right? So it gives some different value, right? If it is 30 Celsius, it gives different voltage, like that. You have to actually go through the data sheet as well, right? So I go through the data sheet. I'll show you how to calculate the final Celsius value, right? So so this is as I said before, it can have different states, right? That basically means it have it is a, so this, okay, so this sensor is an analog sensor, right? It can have several states, right? That's depending on the temperature, right? Based on the temperature, it gives different values, right? In here also we have 3 pins, right? First one for the ground, you should connect with the ground, right? In the practical, did they tell you how to use this breadboard? How the breadboards are connected? Yes or no? Okay, yes, right. In breadboard, so these things are connected. If we give some voltage to this point, we can take the output from this point, right? So pin A1, someone asked what is the purpose of giving this pin A1? I just use it for the verify whether my calculation is correct or not, right? Don't worry about that, right? In the breadboard, so these two sections connected like this, right? If you give some value to this end, you can take that value out of this point, right? So this row is connected like this horizontally. This row connected like this horizontally, right? But in the middle sections, this section connected vertically, right? If you give some value to this point, you can take that value out of this point, right? Like that, these things are connected vertically, and these things are also connected vertically. There are no connection between these two, right? Also these two, right? So in here, so the first one is the ground. I connected this. I give ground to this this minus row column, right? This row, right? Then 5 voltage to this row. Then I connected these 2 section with these 2 section, right? Okay. Now I'm going to connect ground pin. So the ground pin connected to this minus row. Then we have power pin. I connected to 5 voltage, right? So 5 voltage is getting by this row connected to this row, then it connected to 5 voltage, right? Like that, we can get 5 voltage out of that, right? So I know this sensor is analog one. It can have many states, right? So the middle pin is V out, or it names as V out data, like that, right? So if it is V out, that basically means it power up and give some voltage out, right? So that's the meaning, right? So I connected that one to pin number A0, right? Now I connected the my sensors, right? Now the coding part, right? So first. So I'm still using this PIR as well, right? So that's why I set up this this one was set like pin 2, no? Yeah, now it's fine, right? Don't worry about this one, right? When commenting the things, right? So I'm going to sense this analog value from A0 pin, right? So don't worry about this as well, right? So we don't need these things as well, right? So first, so this is an analog pin, right? You don't need to specify whether it is input or output. It basically acts as inputs, right? So I didn't put anything on the pin mode, right? So we don't need these things, right? So I'm reading an analog read from A0, and I use double and put some kind of a variable name, right? Then I'm going to print in that value, right? So I start the serial begin at setup, right? Specify the baud rate as this and give some delay, right? Now the things are okay, right? It should start to work. Okay, I should put println in here. Okay, now it's fine, right? So how we going to simulate is by after starting the simulation by click on this sensor, temperature sensor. So this part is cool down the sensor. This part going to heat the sensor, right? You can see the values will be changed based on the temperature, right? And here you can take a plotter as well, right? You can see the plotter. So if we increase in the temperature, so the value will be increased, right? So what is the maximum value it can reach? So this is the analog pin. So what will be the maximum value? Are you guys sleeping because of the weather? Right? So to break your sleeping behavior, you will have an in-class assignment on the next week, I think. Okay. So get ready for that. So the Dushan will do the in-class assignment, right? As you can see, if you change in the temperature of the sensor like this, right? So the value will be changed. This value is a kind of a reflection of a voltage, right? As you can see that you can see it on the plotter as well, right? Then so I need to take the final temperature, but I need to know the final temperature, right? So I have that the sensor value, right? Whatever that value. Then the thing is I should convert that into voltage level, right? So maximum value is 1024. I'm going to divide the sensor value by 1024, right? So that's the basic maximum, right? So it's like 0 and 5, right? 0 by 5 means the voltage sense. Then the maximum value will be 1023, right? So you are reading some value from this part, then I need to translate it to into a voltage value, right? So you can get the sensor value, whatever the sensor value, and the maximum value is also 24 here, right? Sorry for my bad writing. Then you have to multiply it with the maximum voltage 5, right? By doing this, you can get the voltage value, right? In the voltage sense, but in this for this sensor, we should deal with the micro voltages. That's why initially it was 5,000, right? Okay, if I run this thing, yeah, someone asking when we slide in the sensor, why don't we get the minimum of 0 and max of 1024? That basically depend on the sensor, right? So when they designing this sensor, right? So it has some operative voltages, right? So the minimum voltage will be something like 10 Celsius and maximum will be something like 200 or whatever, right? because of that, it can only give some value, voltage value based on this temperature, right? For every sensor, you don't need to exactly get the 0 and the 1024, right? So that's depend on the sensor, right? So it can be either fluctuating around like 0 and 100. It can be there can be some scenarios as well, right? So also there can be some scenarios like, so the voltage will be more higher than 1024, right? This Arduino can read that voltage as well, right? So there are several scenarios, right? So in the most of the time you can't get the 0 and 1024, okay?
So if that happens, so in the graph, will that be always saturated?
Sorry?
If the input voltage exceeds the capability of the sensor, in the graph, will that be saturated at that point of time?
Yeah, that is true. But if we can't read that sensor value, then there are other methods. You can go for the AREF, right? So that basically you are referring external voltage, right? By that you can, so now it's kept like on the 5 voltage now, right? So the 5 voltage is the 1024, right? By using a reference signal, you can go like 10 voltage unless the Arduino is not going to burn. You can map this 10 voltage with 1024, right? Is it clear?
Okay. Yes, sir. Yes.
Right. Now, right, I have my sensor value, that number, right? Then I divide it by the maximum value 1024, then multiply it by 5 voltage, right? Because we have 5 voltage here. Then I'm going to print that value, right? So now we can get the, what is the actual temperature voltage, right? So, right? So at this point, we have the sensor reading as 153. The voltage is it's like 0.75, right? If we increase the temperature of the sensor like this by sliding, you can see that. So that will increase to 1.75, right? Just very small scale like this. At the endpoint, it gives some 0.1 voltage, right? Then the higher value will be 1.75, right? Because of that, we can give some value like this, 5000 here, right? Now we can have much precision, right? So value will be much precise, right? So for the lower end, it give around 97 microvoltages, right? For the high end, 1007.48 microvoltages, right? Then the thing was, now we know the voltage level. Now we know first we know the sensor value, this one. Then we know what is our voltage value, right? Then we should read the data sheet, right? So this is this graph taken by the data sheet, right? This red colored one for TMP36, right? So discard these things. Don't think about these things, right? So just focus on this red color one, right? So as you can see, if it is around like this point, right, we have 50 for the 50 Celsius, it should give some voltage around 1 voltage, right? Then again, we can come up with the point like this place, right? Almost, I think 0.5, right? You can do simple maths, right? For 0 Celsius, it should 0.5, right? You know that, take the y equal mx plus c thing, right? You can work on that. Then you can come up with the function like this, right? So the 500, you know, by so this this distance is 500, right? This is says it's 500, and it's starting from 0 to 50, right? So 500, in here we have 50, right? You can divide and get the final value, right? So this is so by using this data sheet, you can check on the graphs and come up with that equation, right? So the equation will look like this, right? So the first you have to take the voltage in microvoltage level, right? Then reduce 500, then multiply by 10, right? By doing that, you can get the final temperature value in Celsius. Okay, right? So this is just for this this sensor TAP36, right? So that's different from sensor to sensor. Some graphs like this, right? So you have to come up with some equations, right? So most of the time, so we can either deal with that sensor value that we get from analog tree, right? Or you can use the libraries, right? By using libraries, you can take the final value, right? You don't need to do this math part. So that function is inside that library. If you give the input, sensor input as the parameter, then it will return the final value, right? So is it clear? Right, so the simple math, I'm not going to do that one, right? So this is, we have 0.5 range, we have 50 range here. You can divide this stuff and you can get the final equation like this. Okay, then so I'm going to use that equation in my code, right? So I'm using double again, double, then I put temp voltage, the voltage I get from the previous in here from line number 15, right? Then reduce 500, then we should multiply it or divide. I think I have some error in that. And like that, you can get the final number of in Celsius, right? So in here you can even sense in the around 40, right? But in the actual sensor data sheet, that's kept around 20 or something like this, right? But in the simulation, it have some errors, right? So it doesn't think about in that way, I think, right? So like that you can, so the first value is getting by the sensor reading, the second one is the voltage, and the third one coming from that equation, right? So the final one is the
Excuse me,
Celsius.
sir.
Yeah. Yeah, go ahead.
Sir, isn't the final temperature should be 125? Oh, no, it's 0.2 less. That's what I'm asking.
Yeah, that's basically happened because of the, so this is, even though this can be happen in the real world as well. So in the real world, that the precision is very low actually, right? So it can, that's obvious actually, right? You are dealing with the sensors and you can't get the exact value out of that sensors. But for that, if you need the higher precision,
Sir,
in
මේ
that,
ඊයේ practical එකේ ගානක් දුන්න මේ වගේ එකක් voltage එක print කරන්න කියලා. මේ එතකොට line 15 එකේ තියෙන එකමයි use කරේ. හැබැයි අර senval කියන එකට +1 එකක් add කරාම හරියටම high voltage එක print වුණා මේ වගේ පොඩි error එකක් නැතුව.
Yeah, you have to, yeah. That එක තමයි කියන්නේ ඔයා කෝඩ් එකකින් ඒක ඔයාට කියන්නේ මොකක් හරි රිෆර් කරන්න තියෙනවද මොකක් හරි මොකක්ද කියන්නේ මොකක් හරි රෙෆරන්ස් එකක් තියෙනවා නම් එහෙම කරන්න කියලා ඒක කරන්න වෙනවා. ඒක ප්‍රශ්නයක් නෑ. ඒ කියන්නේ මෙතන අපිට ඒ කියන්නේ එක්සැක්ට් අවුට්කම් එක හම්බ වෙනවා කියලා කියන්න බෑ. හරිද? දැන් මේ සිමුලේෂන් එක ටිකක් හොඳයි. අපි මේ ඇත්තට මේක කරා නම් මීට වඩා වෙනස් ඉති. හරිද? මෙතන නිකන් තියෙන අර එහෙනම් මේ දැන් මේක සිමුලේට් කරනවා කියන්නේ අපි හිතනවා මේක 100% වැඩ කරනවා. ඒ ඇත්තටම මේ behaviors ටික තියෙනවා කියලා. But if you doing in the real world scenario, there are so many errors. Even in the sensors or the Arduino board like that, they have we are dealing with some kind of like very erroneous things, right? The thing is, we are just use these things to like prototype some stuff, right? To make it like a live system, right? So we just need to prove some like proof of concept things, right?
Okay, sir. Okay, sir. Thank you,
Right.
sir.
So that's the thing. So we don't need to take that much precision, right? But we can. Yeah.
එතකොට අර මේ හැමතිස්සෙම මේ එකක් ඇඩ් කරා කියලා මේ හරියන්නේ නැහැ නිසා අපිට අර මේ
ඒක හරියන්නේ
ඔක්කොමත් එක ටෙස්ට් කරලා බල තමයි කරන්නේ.
ඒක ඔයාට ඔයා එක මොකද ඒකට කියන්නේ මේ ෆයින් ටියුන් කරගන්න ඕනේ සිස්ටම්.
Okay.
හරි. Right.
හරි සර් thank you.
We have around 24 minutes. The next part is about interrupts, right? Okay, I'm going to do that part as well, right? So now you have some kind of idea about how to use the serial point and how to print the stuff, those things, right? Now the next part is interrupts, right? So interrupt is, so you know that's these even though the processors and all the stuff we are dealing with are sequential, right? So you can't do two work at the same time, right? You can't do the concurrent, right? So in this Arduino, but it is sequential, but it has a thing called interrupt, right? So that kind of like creating an illusion, like if we have a higher clock rate, so it creating that illusion that it is doing two things at the same time, right? So that is the purpose of using the interrupts, right? So to make that illusion of concurrentness, right? Simultaneous, right? In the interrupts, so that will work like this. In interrupts, so suppose this is your code, right? So you are writing your code, and there is a thing called ISR, right? So it's piece of code that is also a piece of function, right? So the logic behind this is, so you can tell your inside your code to do some work if there is a specific condition, do this part as well, right? So in the illusion that will create, so it will look like you are executing the main code, right? By the time you execute it, if that condition is met, in that case, this piece of code also running, right? So that we can see that these two codes run at the same time, right? So we can feel that is working and simultaneously, but you know that the base level that's not going to work, right? So it just creating the illusion, right? I'll do some example, right? So in the Arduino, we have a set of interrupts, external interrupts, timer interrupts, and serial port interrupts, right? So today we're going to discuss about external interrupts, right? So in the external interrupts, so that basically means you are attaching, so suppose, so it's like this, right? You have a code, right? This will like it doing some work like printing some set of numbers, like counting from 1 to 10,000, something like that, doing in the code, right? Then, so this is we are discussing about external interrupts now, right? So that basically means we can give some function for a specific pin, right? So this is, it is pin number 2, right? Suppose it is pin number 2. So I'm coding in my interrupt as if this pin gets some voltage around 5 voltage, right? So I'm writing some piece of code, right? So in somehow if it is get voltage 5, in that case, it will run this piece of code, right? By executing this as well, right? Actually, it's stop at the when the condition is made. At that point, the the main execution is stopped, and we are directing to the that ISR part, the piece of code we are writing for this pin, right? After that, execute that part, then come back to this place and continue the rest of the code, right? So that is the thing happen actually, right? So it's like running and eating, right? So you can set your code like to run, right? So suppose there's a man and that man is running, right? So but by the time he is running, if he feel hunger, in that case the trigger is condition is made, so he is hungry, then he's going to eat, right? So if you see the final behavior, it will look like, so he is running and he is eating, right? If he feel the hunger, then he will eat by, even though he is running, at the same time he is going to eat as well, right? So that is the behavior we look at as the third party view, right? Actually, so the execution will look like this. It's come to executing the main code. In somehow, if the condition know that if he feel the hunger, then at that point he redirect to ISR the piece of code, then come back to that main part as well. After executing that piece of code, come back to this place, then again executing the rest of the code, right? That can be this we can go redirect to this piece of code at any time, right? So even though inside this piece of code, it can trigger the same thing, right? So is it clear, right? Even though if suppose this is that the eating part, that if he feel the hunger, so he start to eat, right? So inside this as well, if he feel the hungerness, it will start to eat again, right? So this will this function call again and again as well, right? So is it clear? So in the baseline, it has main code. We have that piece of code for that special scenario, right? So normally these things will execute. At some point, the condition made. At that point, he will next start to execute this piece of code, right? So even though inside that executing this instruction, if it is again that condition made, again it will start to execute this piece of code, right? Okay, is it clear? No? Okay, I'll do example, right? So since this is external interrupt, right? So we have in our Arduino Uno board, we have only 2 pins to use it as external interrupts, right? So if it is pin number 2, digital pin number 2, we should refer it as 0, and pin number 3 referred as 1 inside this interrupt thing. All right? So the function is called attach interrupt, right? So in here, so the first at the setup point, you have to specify the attach interrupt. So this interrupt is either 0 or 1, right? If we put 0, that basically means we are referring digital pin number 2, right? If we put 1 here, that basically means we are referring pin number 3, right? Then you should specify the function, right? The piece of code. Then you have to set the mode, right? Mode means function, you know. In the mode, you have if we consider a one signal, right? So in one signal, we have these 4 states, right? Right. So first, this part is low, right? This is high, and this is the rising edge, right? So it's rising from low to high, right? if suppose we are give some signal like this, right? So this is the rising edge, right? And this is the falling edge, right? And this is the maximum. In our case, that is low. And this is the minimum, this is the maximum high, and this is the low one, that is basically considered as low, right? So these are the 4 states, right? Low, rising, falling, high, and we can have change as well. If the signal is changed, at that case, this function will call, right? So if you take a example, right? So example is, so I put 1 here. 1 means I'm connecting some sensor to digital pin number 3, right? So if there is a condition, like if that pin sensor high voltage, that means almost 5 voltage, in that case, so this my function that this piece of code should execute, right? Is it clear? If you put low here, if the low voltage sends to pin number 3, right, then this function will call, right? If you put rising here, if the signal is rising, at the rising, if it is sense signal is rising, at that point, this function will call, right? Is it clear? So I'm going to give assignment. If it is not clear, please ask. Okay.
Excuse me, sir.
Yeah.
So like we do the interrupt and there's like a certain condition, right? So, and then we execute a function when that condition happens.
Yeah.
So like what is the difference between like putting a if condition in the main loop and then executing that function and using an interrupt?
Yeah. So this is like this, Puta, right? So if you put if condition here, right? So you are executing from top to bottom, right? So the first instruction will execute, right? Suppose, okay, I'm put a digital pin number 3, D3, right? So in here you have your if else code, okay? Then you have very bulky set of codes, and suppose, so I'm giving some, okay, I'm pressing a button, right? So by pressing this button, suppose this pin number 3 getting voltage 5, right? Right. So this if condition is at the very start of the execution, and we have very lengthy code, right? So what will happen? So by pressing this, so my behavior is I need to get this kind of behavior, right? So there is a very big code. Inside that code, by pressing this push button, this is push button, right? I need to light up a LED. Okay. So what will happen now, right? So in here you have your if else code, right? So I'm going to start executing. Okay, I'm pressing at the before the if part. So will it light up the LED?
Yes, sir.
How come it will light up the LED before the if else part?
So before the if else, there's some code.
Yeah.
Okay, then
no, right? You have if it is inside the if else, right? Then you press the push button, that will light up the LED, right? No issues, no? Then after that, what will happen? Will it light up? No, right? So unless you come into this if else part, but that is the illusion we're going to develop, right? So in the interrupt, that is in the hardware level, right? So we are putting this external interrupt, right? I'm putting that piece of code to light up the LED. So this piece of code executing normally, right? So by the time if I press this push button, so this will detect, okay, I'm getting high voltage. Okay, I should stop the execution at this point. I should redirect to this point. Then I should light up the LED. So, okay, I'm done. Then it will come back to this place, right? So we are reading this with the set of like a megahertz level, right? So this will look like a simultaneous work, right? So we can see it doing some work at the right hand side, it doing some bulky work. Also, it will responsive to my push button, right? So since this is a very high clock, we can see these two is work like that at the same time, right? It will create that illusion, right? Is it clear?
Yes. Yeah.
Right.
Thank you.
Then, yeah, these are the 5 states we have, right? This is rising edge, this is falling edge, we have low, high, and the change of the signal, right? Then, okay, I'm going to do some example, right? Okay, we have 10 minutes, right? So in here, I'm going to do like, so this is the behavior of my code, right? So I'm printing, there's a for loop, right? There's a for loop, I'm printing numbers here, okay? Then I'm, by pressing this button, I should light up this pin number 13. So pin number 13 is coupled with this LED, right? So if I press this button, then it will give pin number 13 high voltage. In that case, this LED will light up, okay? So that is the behavior of the codes, right? So my code start to count from 0 to 100, right? So by the time if I press this button, it should light up the LED as well, right? So that is simultaneous. If we run this piece of code, right? So it will look like this. Also, it will respond to my clicks, right? Even though I keep pressing this push button, that will still work, right? As you can see, the counting will not going to stop, right? So, right, you can see like, okay, that is this Arduino working, doing 2 works at the same time. As you can see, the LEDs light up now, as well as it keeps counting the numbers, right? Right, we can see this is kind of illusion, like this is concurrently like a parallel doing 2 works, right? But in the base level, that is not the case, right? Okay, so this is how I'm going to do my code, right? So first, okay, we have, so my push button. So if I press my push button, I should light up a LED, right? So first, it should sense the reading from pin number 3, right? In that case, we should specify pin number 3 as input, right? Then I should write some voltage, high voltage, to this pin number 13, right? So out of this pin number 13, in that case, this LED will light up, right? Okay, so it's sensing my state coming from by pressing this push button, then it will write some high voltage out of this pin number 13, right? With that, this LED will light up, right? In that case, pin number 3 is the input, pin number 13 is the output, right? Then I'm using this serial monitor. Because of that, I define the baud rate as serial begin 9600, right? Then I'm going to attach my interrupt, right? So attach interrupt. I use the number one referred digital number, pin number 3, right? If I put 0 here, in that case, you have to remove this from here and put it into pin number 3, so pin number 2, right? Right, so I'm going with the previous setup. I'm using pin number 3, right? And the function is called LED, right? Then the mode is high, right? If this pin number 3 sends high voltage, in that case, this function called LED will call, right? So this is inside the setup, right? Then we have the loop, right? inside the loop, I just simply count it from 1 to 100 with the delay of 1 second, right? Okay. Then we have this LED, our ISR, right? So this LED function, first, as I said before, right? So even inside this piece of code, that can trigger another call, right? So even though when executing this LED function, if this condition met, again, it will stop the execution at that point and again call the LED function, right? Because of that, so the first thing we should do is we have to detach our interrupt, right? That means pulling out our interrupt, right? So turn off in the interrupt, right? So the interrupt attached to pin number 1 now. So the keyword is detach interrupt. You have to give the pin number 1, right? Then I'm taking the state of my pin number 3, right? So if I pressed, if it is high voltage, in that case, it should light up the LED simply now, right? I can simply digital write that like this. If the button state is high, in that case, we write in digital, write 13 high voltage. Otherwise, I'm writing digital pin number 13 low voltage, right? So this is the piece of behavior I need, right? After that, I should again attach my interrupt, right? Okay, first at the very beginning, I pull out the interrupt, then I did my work, right? Then I attach my interrupt, right? So if you don't need that, by doing this, you are basically lowering your sensitivity. But the scenario is this piece of code is very a critical thing. So we know that we should like completely execute this function, right? That's why we are putting this detach interrupt. Otherwise, if you didn't put the detach interrupt, that okay, someone asking what is the purpose of the 1 inside the attach interrupt? Yeah, 1 means, Puta, 1 means if you put 1, that basically referring digital pin number 3, D3, right? So I connected into D3 here. Can you see that, right? So if we put 0, that basically means I'm attaching my interrupt to digital pin number 2, D2, right? In Arduino Uno, we have only 2 options, 2 and 3, right? Pin number 2 or 3. I think in the Arduino, most of the Arduinos, we have only 2 external interrupts, right? So either it can be pin number 3 or pin number 2, right? Right. So that if we consider in 2, in that case, we should put 0 here, right? If we consider in number 3, we should put number 1 here, right? So for now, I remove my detached interrupt part, right? So it's going to work, right? As you can see, these things will work, right? Even though I press the button, still the counting will happen, right? So this is, we are using this detach interrupt to specify the, like, to do that our LED part, this piece of code complete, right? Otherwise, again this LED function will call, but it won't come to the end of the function, right? Okay, now okay, I'm going to change the mode here. So initially it was high. If it is field 5 voltage, it will trigger, right? Okay, now I'm going to put rising. Right? Still you can see it is working, right? By clicking that, the what is behind on the back is the work is like this. So the initial, the in pin number 3, it says some voltage like this. By clicking this, pressing this button, it will give some 5 voltage, right? After released, it will come back to the previous state, right? So this is the rising edge, right? So only at this point, this LED function will call if you put rising, right? But if you put this high voltage, at the every time it feels this voltage high, it will call, right? Also, we can use this falling falling as well, right? Right, that is, we can't see that difference, but actually, so in the inside, now if I press this button, if I put falling here, right, now the execution occurred only at this point, right? So at the very beginning, it was occurred that when it feels the high voltage, right? Then at the rising edge, I put rising, then it will call the function every time it feels that signal is rising, right? Then after that, if you put falling here, right? So it will call the only at this point, right? So we can't see the difference because these things are executed in very fast, right? So we can't see the difference, right? Okay, so
if you keep it pressed down.
Sorry?
If you keep it pressed down, sir, it shouldn't light up, right? Since it's like a press down button, like falling should happen when you release it.
Yeah. Theoretically, you are correct, but yeah. So there's another issue as well. If you put low here, right? That also not going to work, right? So so now I put low, right? So low means basically if it feels 0 voltage, then it should occur, no, right? So the trigger, right? But in this sense, that's not going to work, right? Because, right? So the thing was, there are some voltage issues, right? Actually, if we consider this thing as low.
So උඩ දැනත් වෙනස් වෙන්න ඕන නේද?
උඩ එකක් තියෙනවා. ඒක වෙන්නේ තතෙන්ට issue එක වෙන්නේ. මෙතන අපි දාමු 40.
එන්න එතන මේ attach interrupt එක කොහොමද LED function එක ඇතුලේ?
මම detach කරොත් නම් attach කරන්න ඕන. මම detach කරොත් මගේ function එක ඇතුලේ
කොහොමද attach interrupt එක call කරද්දී ඒක
නෑ මෙහෙම වෙන්නේ. දැන් මම LED දැන් මේ attach එක interrupt එක දැම්මම හරිද? දැන් මෙයා call වෙන්නේ මේ function එකේ LED function එක. හරිද? දැන් මම ඒක පටන් ගන්නකොට කියනවා හරි දැන් interrupt එක ගලවලා අයින් කරන්න කියලා. නැත්තම් again and again ඒක call වෙන්න ගන්නවනේ. හරිද? ඒක නිසා මම ඉස්සෙල්ලා ගලවලා මගේ වැඩේ කළා. ආපහු interrupt එක දාලා තමයි එළියට එන්නේ function එක. හරි?
එහෙම නැත්තම් අපිට මේ loop එක ඇතුලේ use කරන්න පුළුවන්. interrupt දැම්මේ නැත්තම් LED function
LED function එකේ
දැන් interrupt නැතුව අග interrupt එක නැතුව යනවා නම් LED function එක
නෑ loop එක ඇතුලේ කොහොමද දාන්නේ? හරිද?
loop එක කියන්නේ අර මේ main loop එක. අන්න එතන.
මේක නෑ ඒක ඇතුලේ දාන්නේ නෑ. මෙහෙමද වෙන්නේ. හරිද? So this is the setup, right? This will run for only once, right? So this is the loop that will again and again runs, but in sequential, right? So we have another piece of function, right? So that is out of this setup and loop, right? So even if there is a condition made like falling or high for an external interrupt, in that case, this function will call, right? So if you put this inside the loop, right? That basically inside the void loop, right? So that basically executing in the sequential manner, right? So that is, there are no point of inserting that into this loop, right? So So we need to do two or three works, right? So we are executing loop, and by the time if there is a condition met, so we should execute this piece of code as failed, right? So it seems like we are executing both these functions, loop function and the LED function, right? So if we put this LED function inside the loop function, that basically inside the loop function, right? Okay.
Oh, it's I mean, there's someone setup එක කරන්නේ අර initially අර init වෙන අවස්ථාවේ කියන්නේ අර initialize වෙන වෙලාවෙ විතරයි.
විතරයි.
එතකොට ආපහු අපි attach interrupt එක call කරද්දී
නෑ එතන වෙන්නේ මෙහෙමයි. ඒක අපිට attach interrupt එක ඕන තරකින් දාන්න පුළුවන්. හරිද? අපි normally setup එකේ practice එක තියෙන්නේ setup එකේදී තමයි interrupt එක දාන්නේ කියලා. හරිද? අපි loop එකේ දැම්මොත් again and again වෙන නිසා තේරුමක් නැහැ එතන දාලා. හරිද? එකපාරක් දැම්මම interrupt එක දිගටම තියෙනවා. ඒක නිසා setup එකේ තමයි දාන්න ඕනේ. හරිද? අපි setup එක execute කළා ඉස්සෙල්ලම එන්නේ loop එකට. හරිද? මේක මෙතන trigger වුනේ නැත්තම්. හරි? එතකොට මේ loop එක execute කරගෙන යද්දී මේ අපිට pin number 3 වලට high voltage එකක් හම්බුනොත් එයා මෙතෙන්ට එනවා. හරිද? මම detach එක දැම්මේ detach කරන්න ඕනේ. හිතන්න මම දැන් මේක හෙන bulky කියලා. Hariද? Suppose this is a very bulky code, right? So in that case, so inside this LED function, so we execute it line by line. In somehow again that interrupt is triggered, right? So again I'm sensing some D3 sensing high voltage again, so it started from the beginning. It's calling this LED function, right? So suppose there are so many lines after this when it's calling that function, right? So something like this, right? So this is our that piece of function, right? So it is very bulky one, right? So now I'm at the very beginning, I'm executing line by line, right? Again, that external interrupt is called, right? So it sends 5 voltage, it's triggered. Again, it's stopping at executing this one. Again, it's called the same function, right? So it doesn't complete this piece of code, this piece of function, right? So in normally we are using interrupt in like a very critical scenarios, right? If we can't complete that function completely, so that is making some errors, no? That's why at the very beginning we are removing the interrupt, right? So we are removing the interrupt, right? At the time, okay, now I'm executing, even though the previous that condition is made, so it's not going to stopping the execution, it's keep executing this stuff, right? After that, it's again attach the interrupt and coming out of that function, right? By the time if the condition is met, again it will call the LED function, right? Okay.
Excuse me, sir.
Yeah.
මේ අතන සර් මේ attach interrupt එකේ falling තියෙන තැනට low දාපුවම වැඩ කරේ නෑ නේද සර් කලින්?
ඔව්.
ඒක සර් මේ අර high win line එකේ තියෙන button state එක low වලට මාරු කරන්න වෙයිද සර්? එතකොට වැඩ කරන්නේ නේද සර්?
මොකද්ද?
දැන්
නෑ මෙතන දෙකක් නෑ මෙතන දෙකක් conditions දෙකක් තියෙනනේ අපිට. button state එක high නම් high වෙනවා, low නම් low වෙනවා. මම මොකද press කරන්නේ නැත්නම් මෙයාට sense වෙන්න ඕනේ low එකක්.
ඔව් ඒක low එකක් වුණාම මේ light එක පත් වෙන්න ඕනේ නේද සර් LED?
මේ මෙතන මාරු කරන්න ඕනේ කියලා ඔයා කියන්නේ.
ඔව් සර්.
right.
එතන නෙමෙයි සර්. අර button state එක එහෙම මාරු කරත් හරියද? ඔව්
මෙහෙමද?
එතකොට set වෙන්නේ නැද්ද?
නෑ ඔතන මෙහෙම issue එකක් තියෙනවා. ඔතන issue එක මේ දෙක ගන්න interrupt දෙක කියලා. but state එක low නම් digital 13 එක high එකක් එන්න කියලා කියන්නේ.
ඔව් sir.
මෙතන වෙන්නේ මෙහෙමයි. So if you using this kind of so low means if we are like in the Arduino, right? So if we around like, so this is the 5 voltage, right? So and this is kind of a 3.7 or whatever, right? So this area is considered as high voltage, right? So this is the accuracy, right? That's the precision. It has not the exact value. It has set of range, right? In this case, I think, right? So the issue was, so this value is not low, right? So even though if we didn't give any inputs, right? Even though it feels some kind of, it has certain voltage, right? Suppose 2 volt in, so this is for the high voltage. For the low voltage as well, so this is 0 voltage, and up to like 1.7 or something like that, this area is considered as low, right? So the thing is, I think that this condition is not occurred because there are some voltage inside this pins, right? So because of that, it won't trigger, right? So because of these things, I didn't tell you these things because you will getting some bad idea about the accuracy, right? So in the Arduino, it won't, like, it doesn't have that precision accuracy, right? So if it is 5 voltage, it doesn't mean exactly 5, right? It has certain range, right? 5 to 4 voltage or like that. If it is 0, even though it doesn't mean 0, right? It has some it has some range, right? 0 to 2 voltage or something like that. I think it's almost 12. Yeah.
අර assignment එක කරද්දි මම මේ වැරදිලා මම දැක්ක දෙයක් අර මේ බටන් එකේ ස්ටේට් එක ලෝ වෙලා තියෙද්දි LED එක පත්තු වෙන්න මේ අර ඔය රෙසිස්ටර් එක මේ
මාරු කරනවා.
ඔව් ඒක මාරු කරන්නේ එහෙම නැතුව ගියාම මේ
ඒක මාරු කරන්න පුළුවන්. ඒක මාරු කරලා ප්‍රෙස් කරද්දි ඔෆ් වෙනවා, රිලීස් කරාම ඔන් වෙනවා. Similarly, if we replace push down button with TMP36 and use falling down, it will work. Someone asked me whether we can replace this push button with TMP36 and use falling. Falling down means you mean falling. It will work. So TMP36, yeah, we can do that, but TMP36 getting some like range of values. Yeah, you are mean like about this high and low thing, no? Yeah, that will work, right? So I'm giving you a assignment. I forget to tell you that. So this assignment is, so this one, assignment 3, right? So in this case, you have to, do you guys need more time for the assignment 2? No?
That will be good, sir.
That will be good. Oh, I didn't hear you.
That will be good.
Okay, right. Okay, I'll give you. Okay, then you can do the submission at the next week, right? So both assignment 2 and assignment 3, right? The assignment 3, you have to do some behavior like this, right? So you have a temperature sensor in your room, right? That basically sensing the room temperature and printing that value on your serial monitor. Okay, right? So then you have this your temperature sensor, then you have your PIR sensor, right? If someone move around your room, it should detect that at the very real time, right? Then it should print a warning message, right? So it has 2 sensors, temperature sensor TMP36 and human movement detector PIR sensor, right? So it's keep checking the temperature, right? So this is about interrupts, right? It's keep checking the temperature. If the PIR sensor detect movement, then it should print a warning message on the serial monitor, right? that is the assignment 3, right? So I think with that we can stop today's lecture, right? It's almost 12:15, right? So if you have, yeah.
මේක ඒ කියන්නේ මේකේ ටිකක් තේරුම් නැහැ කියන්නේ සර් මේ ටෙම්පරේචර් එක චෙක් කරනවා මේ හියුමන් movements උත් check කරනවා. එතකොට
Oh,
කොයි
they go check.
වෙලාවෙද warning එක පෙන්වන්න ඕනේ?
No, no. We should keep checking the room temperature, right? You can't stop checking the room temperature. Okay, it should print 10 Celsius, 20 like that. It's keep checking the room temperature, right? So it's doing some work, right? If there is a person inside the room and if he's moving, in that case, it's that PIR sensor triggered that one. Okay, there's a man or the movement. In that case, by the time it's printing these temperature values as well, it should print that warning message. Okay, there is a movement inside your room, right? So this part is coming. So this detecting part coming from the interrupt, and this is the base program. Okay.
Okay, okay, thank you, sir.
Okay, then thank you for coming. I'll stop at this point, right? So you will have a assignment. So I'll give you more time for this one, right? You will have a assignment based on analog part and this physical computing part, the mixed one, right? So the dates will be announced by Dushan, okay? Right? If you have any questions, you can either mail me or contact me, okay? Okay, thank you for coming, okay?